I will use this example to demonstrate Bayes' formula. So let's first read the text. Bayes' formula. Suppose that the sample space S is partitioned into two sets B1 and B2. For any set A, so we want to calculate the conditional probability of B1 given A. So in this formula, the first step, this part, so this is just by the definition of conditional probability. Okay, and so for the second part, for the numerator, yeah, so this is just the so-called multiplication rule, basically to get the intersection of two sets, right? And for the denominator, so this is just apply the law of total probability. And similarly, the conditional probability of B2 given A is very similar. Yeah, so let's try to use the following example to demonstrate how to apply the Bayes formula. The example says, suppose there is a very reliable test for a certain type of cancer. Yeah, so for this type of problem, so we also need to draw a diagram to help us to solve the problem. If one has cancer, so then the test will be positive with probability 0.96. If one does not have cancer, then the test will be negative with probability 0.96, 94. Sorry. Yeah. So basically, for a person, there are two possible scenarios, right? So has cancer or no cancer, right? Yeah. So let's draw a diagram. Okay. So can be cancer and no cancer. Okay. According to the okay, no cancer. So according to the problem, one out of 145 people, so in the age group, have the cancer. So this probability is 1 over 145. Okay. And so when a people to take the test, so the result can be positive or negative, right? So the result can be positive and the result can be negative. Okay, and in this case, the result can also be positive, result can be negative, right? And according to the problem, so if one has cancer, so the probability of positive is 0.96. And so if one does not have the cancer, the probability of negative is 0.94. Okay, so if we compare with the formula, so we will know the event. Yeah, so basically the question is one. So one gets the test and it comes out to be positive. So what is the probability that this person has cancer? Okay, so we will have B1, B2, right? So B1, we can see B1 is cancer. So B2 means no cancer. And A just means the test is positive. Okay. So we want to. Okay. So before we proceed, so there are some probability is missing, right? Yeah. So we use the relationship. The sum of probability is equal to 1. So for a person, so it can have cancer or no cancer, right? So basically the probability of this one and this probability should be 1. Okay. So this is 1 over 145. So here should be 144 over 145. Yeah, so similarly, the probability of positive is 0.96. So this one should be 0.04. So the probability of negative here is 0.96. So here should be 0.06. Okay. Now we want to calculate the probability of cancer B1 given A, right? Yeah, so we use the first formula, okay, and so first step, just by the definition of conditional probability, right? So this is just P B1 intersect A over probability of A, right? Yeah, and for the numerator, okay, so use the multiplication rule. So this is probability of B1 times probability of A given B1. And so for the denominator, so we just apply the law of total probability, right? So this is probability B1 times probability A given B1 plus probability of B2 times probability A given B2, right? Yeah, so for each of the probability, we have already we have already identified the value in the diagram, right? Yeah, so for example, so basically, so these two, right? Yeah, so they are just the P1 and P2. And for the value in this level, and so they are just the conditional probability. Okay, so we just plug in the value. Okay, so probability of B1 is cancer, right? Okay, and so this is 1 over 145 times probability of A given B1. Yeah, so will be this one, 0.96. And so the next one, in the denominator, okay, so this is 1 over 145 times 0.96 plus 1 over 44 plus 145 times 0.06, right? And so then if you do the math, and so you will get the final answer, and so the answer will be 0.1, okay, or just 10%. Yeah, so if you are confused about basically how to get this denominator, yeah, so just recall so how we calculate the total probability. So this is essentially basically this is just PA, right? A is positive, so we just find out, identify the path that will lead to positive. So there are two possible scenarios, right? So from here, along this path to positive, or along this path to positive. So basically, so this expression, so essentially we just multiply the number along the path, and so add the two paths together. Okay. Yeah. So basically, so in this example, so we just demonstrate how to apply Bayes' formula to calculate a conditional probability.